Hello friends, you already learned four different number systems, that is binary, decimal, octal and hexadecimal. Today we are going to learn how to convert one number system to another number system. Basically there are 8 methods through which we can convert one number system to other number system. So we will start with the first method, that is any number system into decimal number system. Now we'll take one example. The given number is in a binary format. Let's take an example. Binary number, that is 1 1 0 1 0 dot 0 1. This is a binary number, and we are going to convert this binary number into decimal number system. So let's start with the integer part. This is the integer part, this is the fractional part. The given number is having a base 2 because this is a binary number. So 0 into 2 raised to 0, because the given number is in a binary format, plus 1 1 into 2 raised to 1 plus 0 into 2 raised to 2 plus 1 into 2 raised to 3 dot, as it is 0 into 2 raised to minus 1 plus 1 into 2 raised to minus 2. Now you need to do the addition of this integer part. So 2 raised to 3 is equal to 8 plus 0 into 2 raised to 2 is equal to 0 plus 1 into 2 raised to 1 is equal to 2 plus 0. Here 0 plus 0.25. So here you get 10.25. That is in a decimal format. So this is how we can convert binary number into decimal. Let's take an example of octal number. You have to follow the same method to convert any number into a decimal. If the given number is in octal format, then the given number is having a base 8. So you need to multiply integer part starting from this first one. You need to multiply with 8 raised to 0, 8 raised to 1, 8 raised to 2 and so on. And similarly in fractional part, 0 into 8 raised to minus 1 plus 1 into 8 raised to minus 2 and so on. And remaining portion will be the same. If given number is in hexadecimal format, given number is having a base 16 and you have to convert that into a decimal, then you have to multiply this number with 16 raised to 0, 16 raised to 1 and so on. In the fractional part, 0 into 16 raised to minus 1, 16 into minus 2 and so on. Remaining will be same. So this is the first method, that is to convert any number into a decimal number. Let's take an example of octal to decimal conversion. The given number is in octal format, that is 365.24, and we have to convert that number into decimal. So as we discussed earlier, we have to multiply with 8 raised to 0, 8 raised to 1, 8 raised to 2 and so on in integer part. In fractional part, 2 into 8 raised to minus 1, 8 raised to minus 2 and so on. After that, we have to do the separate addition of integer part. So 8 raised to 2 into 3, 192, here 48 plus 5 dot as it is, and 2 into 8 raised to minus, that is 0.25 plus 0.0625. So addition of integer part, that is 245 dot 1325, that is a decimal number. So 245.1325 decimal number is a equivalent of this octal number. Now we will take another example of hexadecimal to decimal conversion. The given number is in hexadecimal format, that is 4C8.2, and we have to convert that number into decimal. So we have to follow the same method. Integer part 8 into 16 raised to 0, because given number is in hexadecimal format, plus C. Here C will considered as a 12. If A is here, then we have to consider 10, B 11, D 13, E 14, and F then 15. Okay, so here given number is C, so we have to consider decimal equivalent of C is 12. So 12 into 16 raised to minus 1, here 4 into 16 raised to 2, and so on. And in fractional part, 2 into 16 raised to minus 1. So addition of this integer part, that is 1224 dot 125. So this is how we can convert hexadecimal to decimal. Now we will learn second method, that is decimal to any number system. So we will take an example of one decimal number. The given number is 105.42, that is in decimal format, and we are going to convert that decimal number into binary number. So to convert from decimal, we have to follow the same method. There is a separate method for integer part and separate method for fractional part. We'll start with integer part. Integer part is 105. So in integer part, we have to use division method. 105, we are going to convert this number, decimal number, into binary. So we need to divide with this number with 2. 105 by 2 is equal to 52, and one remainder. 52 by 2 is 26, 0 remainder. 26 by 2, 13, 0 remainder. 13 by 2, 6, 1 remainder. 6 by 2, 3, 0 remainder. 3 by 2, 1, 1 remainder. And 1 by 2, 0, 1 remainder. So this remainder is a binary equivalent of this integer part. Now when you write the answer, this will be the most significant bit of your answer, integer part answer, and this will be the least significant bit answer. So your answer for integer part will be 1101,001 in binary format for only fractional part. Now we will learn how to convert decimal into binary only fractional part. Fractional part is 0.42. So in this method we have to use multiplication. So 0.42 into 2, because we are going to convert that into a binary. So answer will be 0.84. Here integer part is 0. 0.84 into 2 is equal to 1.68. Here integer part is 1. Now here we have to consider only fractional part. So 0.68 into 2 is equal to 1.36. Integer part is 1. Here only considered 0.36 into 2, 0.72. Integer part 0, that's why 0. 72 into 2 is equal to 1.44. Integer part is 1. So you can go up to the 4 or 5 digit, and this integer part, carry part, is your answer for fractional part. But here this one will be the most significant bit and this one will be the least significant bit. So your fractional part, answer of this fractional part is 0.01101. So combinedly, the given question was 105.42. The answer for that number is 110.001 point, fractional part 01101. So this is binary portion. Now if the given number is decimal and you are going to convert that number into octal, so in integer part you need to divide with 8 instead of 2, and remaining portion will be the same. If you are going to convert a decimal into a hexadecimal, same, you have to follow the same method, but you have to divide with 16 instead of 2, and this will be your answer for integer part. Now in fractional part, when you convert decimal into hexadecimal, then you have to use 16 instead of 2, and when you are converting decimal into an octal, then you have to use 8 here instead of 2. So this is the second method to convert decimal into any number system. Let's take an example of decimal to octal conversion. 105.42, that is a decimal number, and we have to convert that into a octal format. So we have to use separate method for integer part here and one separate method that is for fractional part. So in integer part we have to use division method, in fractional part we have to use multiplication method. So we'll start with integer part. As we discussed, integer part A 105, and we have to divide 105 by 8. So 13, 1 remainder, 13 by 8, 5 remainder, 1 quotient, 1 by 8, 0, 1 remainder. And this is a octal equivalent of this integer part, but we have to consider this bit is a most significant bit and this bit is a least significant bit. So 151 is a octal equivalent of 105 decimal. In fractional part, we have to multiply with 8 because we are going to convert this decimal into octal. So 0.42 into 8, 3.36. Remaining integer part or carry is 3. Now 0.36 into 8 is equal to 2.88. 2 is a carry bit, point as it is, 0.88 as it is, into 8, 7.04, 7 as it is, 0.04 into 2 is equal to 0.32, 0 as it is, and 0.32 into 8 is equal to 2.56, 2 as it is. So this is a octal equivalent of 0.42, and here in fractional part, this one will be the most significant bit and this one will be the least significant bit. So this entire answer, 151.32702 in octal format, this is a octal equivalent of this binary number. Now next example, that is decimal to hexadecimal number. We are going to use the same number, that is 105.42, that is in decimal format, and we are going to convert that into a hexadecimal. So as we discussed earlier, division method for integer part and multiplication method for fractional part. So 105 divided by 16 because we are going to convert into hexadecimal. 6, 9 remainder, 6 by 16, 0, 6 remainder. So this one will be the most significant bit. So write your answer is 69, 69. In fractional part, same method we have to follow as we followed earlier, but here when we use a carry bit, here is a 6, here is a 11, but we are converting the number into hexadecimal, so we cannot write 11 directly in your answer. We have to convert that into hexadecimal. So 6, here B 11, so we have to write B 8, 5 and 1. So this is the most significant and this is the least significant bit. So our answer is 69.6B851 in hexadecimal. Now we will learn third method, that is binary to octal. The given number is in a binary format. To convert binary number into octal, we need to form a group of 3. So for integer part, we'll start from here. So this is a group number 1, this is a group number 2, and this is a group number 3. And for fractional part, this is a group number 1 and group number 2, we can add 2 0, but there is no point to add 2 0 at the end. So we are not adding this. Here to form a group of 3, we need to add 1 0. So dash as it is. We'll start from integer part. 0, 1 0 means 2. Octal equivalent of this number is 2. Octal equivalent of this number is 110 means 6. 010 again 2. Dot as it is. 011 that is 3, and again 0 0 3 0. It is octal equivalent to this binary number. Now we will learn the fourth method, that is binary to hexadecimal number. The given number is in a binary format. and we are going to convert that into a hexadecimal number. It is very simple method. Instead of making a group of 3, we need to make a group of 4. So we'll start from integer part, group of 4. So this will be a group of 4, again group of 4, a group of 4, again this is a group of 4. So it is 4 group, and for fractional part there is no 0 available, so you can add 30 over here. 1 0 2 0 3 0. So what is the binary hexadecimal equivalent of 0 1 1? It's a 3. 0 1 1 0 means 6. 1 1 0 means C. 1 0 1 1 it's D. Dot as it is 1 0 0 0 means 8. So what is the hexadecimal equivalent of this binary sequence is DC63.8. DC63.8. That is in hexadecimal format. This is how we can convert binary into hexadecimal number. Now method number 5, that is octal to binary. So given number will be in octal format and you have to convert that into a binary format. So it is very simple. The given number is 237.25, that is in octal format, and we are going to convert that into a binary. So we'll start with integer part. 7. What is the binary equivalent of 7? It is 1 1 1 1 1 1. What is the binary equivalent of 3? That is 0 1 1. And what is the binary equivalent of 2? 0 1 0. Dot as it is, what is the binary equivalent of 2? That is 0 1 0. And what is the binary equivalent of 5? It is 1 0 1. So that's it. You need to write in proper way. It means 0 1 0 0 1 1 1 1 1 dot 0 1 0 1 0 1. That is the binary equivalent of this octal number. So this is how we can convert binary number from octal number. So now we will learn how to convert hexadecimal number into a binary. So the given number will be in hexadecimal format and we need to convert that into a binary. So in hexadecimal number we need to write hexadecimal equivalent binary number. So we'll start with integer part. What is the binary equivalent of B? 1 0 1 1 0 1 1. What is the binary equivalent of, that is, what is the binary equivalent of A? So 1 0 1 0 0. Dot as it is, what is the binary equivalent of 0? 0 0 0. And binary equivalent of 8? 1 0 0. So this is the binary equivalent of this hexadecimal number. We need to write in proper way. That means 1 0 1 0 1 0 1 1 1 dot 0 0 0 0 1 0 0. That is binary format. So this is how we can convert hexadecimal into binary number. Now 7th method, that is octal to hexadecimal conversion. To convert into hexadecimal from octal, we need to convert octal number into a binary. That is already been discussed in method number 4. And after that, that binary number need to convert it into a decimal number. That is already been discussed in method number 4. So this is how we can convert octal into hexadecimal. Now last method, that is hexadecimal to octal. So to convert into a octal from hexadecimal number, we need to convert hexadecimal into binary, that is been discussed in method number 6, and then binary number need to convert it into a octal, that is been discussed in method number 3. So this is how we can convert number from one number system to another number system. Thank you.